Let's power it on. Also gonna power on the test source. Use it as a source for my tracer. There we go. The first module I designed for my rack was in fact a signal tracer. One problem that I had with it was that the chip I used as an amplifier for the speaker, the DDA 2822, is very sensitive to noise. So it picks up noise from the ESP, it picks up noise from the display. There was a bit too much noise in the audio, so I decided to design a new one. And I wanted to go with a digital amplifier. I had one that I used in several projects with an I2S input. So I needed a digital input. So I decided also to add DSP to it, which is largely overkill. But I used DSP in my audio processor and speech processor in my previous videos from the CB projects. And I bought a lot of these for projects that I had in mind but didn't go through. So I had these available. So that's why I used the DSP in that. The DSP takes care of part of the amplification. There's a filtering in it, digitalization, control of the output amplifier, level sensing, envelope detecting, and so on. So that's all handled by the DSP. So I have the input attenuators, 0, -20, -40, -60 dB. So I can attenuate 110, 100, 1000. There's also an automatic fallback scheme. So if I have an overload on my input, then it will automatically switch back to a lower setting. So I can mute it as well. I have also a scope function in here. Simple basic oscilloscope. I can control the amplitude or automatic. There's a spectrum analyzer, very basic spectrum analyzer. It will automatically go to the peak, or I can change to one of the other bands as well. One of the other functions is a monitoring function. Let me just turn it on for a moment. I can zoom in. I can set some limits. Upper and lower limit. If, for example, I'm working on an amplifier and I know the level is dropping at some point, I don't want to stand there and watch all the time, so I can turn on the monitor function. So I'm looking at the envelope of the signal, the white line, and I can set my limits. So if it goes above or below those limits, well, I have to activate it first. So now it's running. So if I now cross these limits, it sounds an alarm 5 times and it freezes the frame. Let me just mute this for a moment. So this way I can I get a notification when there's a drop or a rise in the level. So that's useful for monitoring amplifiers that have an intermittent issue. I can set a filter. I have a low pass and a high pass filter. I can set the step rate and so on. So very basic. I give some settings. I can set the input amplification, the output amplification, the attenuator for the output, and also turn on the overload protection. Now the overload protection is only behind the input, so the input protection is always on, and the other protection, if my signal is amplified too much, it will go back in volume. it will reduce the volume automatically. So these are the settings. So that's it. So basic signal tracer, mute, volume, attenuator, view meter. I have an additional thing here. So I dropped one function compared to the old signal tracer. I did remove the HF demodulator because I think it's best to do the demodulation in the probe itself. So if I want to have an active probe, I have this connector here, which has plus 5 volt, plus 12 volt, also analog input and output of the DSP. So I can either use the audio input or the audio input on the probe connector. So this is for active probes, or I've seen one signal tracer, an old one, that had an FM demodulator as one of the settings. So that would be interesting to make a probe that does FM demodulation as well. So I can power it from here. I can feedback the audio directly, or I can feedback the audio via the audio in. The signal tracer module, usual display and rotary encoders, audio input, speaker, and a connector for an optional probe. It provides 5 volt, 12 volt, and also analog in and out of the DSP. On the inside is ESP32 and the DSP module ADAU1701, programming jumpers. A lot of information has been discussed already in the speech processor that I published. So have a look at that video for more information on the DSP. Amplifier from Maxim, I2S input, coupled directly to the DSP. Digital sound, no noise if it's off. Relays for the input attenuator. Capacitor for the coupler is outside of the board. That's done because I want to experiment with it. And this blocks the DC, so I can have a high level of DC. The input amplifier is on a small board that plugs in a DIL chip. Why is that? If I find another one, I can just replace it with one in a DIL package or surface mount with an adapter. Some power supply to power on the DSP board. Relay drivers up here.